Hey, today we are going to be talking about properties. So it's going to be a bunch of vocab. Remember that in order to study your vocab, you can use the Quizlet that I made on the website that I made. And it's just an interactive flashcard. Throughout the year, you'll get really used to it with Mrs. White and Mr. Winters. So our first word is properties. Properties are statements that are true for any numbers. So the following words are properties. So that's what we're going to write in our box. The following vocab words. So our first real property we're going to talk about is the commutative property of addition. Some of you may know what commute means. It means to move. So if you want to kind of make a note, commute means move. What it is saying the order in which numbers are added does not change the sum. So you can literally change the numbers around or move the numbers around, and you'll get the same answer if you are adding. So if we looked at an example with numbers that say 2 plus 3, and then that switch it around so it says 3 plus 2. So on the left I got 2 plus 3, which is 5. On the right I have 3 plus 2, 5. And it's true that 5 equals 5, so we're good. So that's just saying that when you add numbers, switch them around, and it doesn't make any difference. Next is the commutative property of multiplication. So it's the exact same thing that we just did, except using multiplication. The formal definition is the order in which numbers are multiplied does not change the product. So let's use 2 times 5 and put it equal to 5 times 2. So on the left I got 2 times 5 is 10. Bring down my equal sign. On the right, 5 times 2, 10. And 10 equals 10, so we're good. The next word is the associative property of addition. It is very similar to the commutative property, but this time it's about how numbers are grouped. So when you have the associative property, you're going to see parentheses. So the definition is the order in which numbers are grouped when added does not change the sum. So let's say we have 1 plus 2 in parentheses, and then plus 3 on the outside, equals, now I'm going to keep the numbers in the same order. I'm just going to move the parentheses around the 2 and the 3. So see how on the left I got 1, 2, 3. On the right I have 1, 2, 3. Just the parentheses moved. So on the left, do parentheses first. 1 plus 2 is 3. Bring down my plus 3. Bring down my equal sign. On the right, do parentheses first. 2 plus 3 is 5. And bring down my 1 and my plus sign. On the left, we got 3 plus 3, which is 6. Bring down the equal sign. 1 plus 5 is 6. So 6 equals 6. That worked out. So when we're adding, you can just move the parentheses around, group them however you want. Sometimes this is helpful when trying to do math in your head. The next term is associative property of multiplication. So it's the exact same thing, except with multiplication. So let's use 1, 2, and 3 again. So 1 times 2 in parentheses times 3 on the outside equals 1 times, now I'm moving the parentheses around the 2 and the 3. On the left I have 1 times 2, which is 2. Bring down my times 3. Bring down the equal sign. And then in parentheses over here, 2 times 3 is 6. Bring down my 1 and my multiplication sign. 2 times 3 is 6. And 1 times 6 is 6. We got the same number, so we're good again. Now it's very important, you cannot do this if there is any subtraction or any division. These properties only work with addition and multiplication. So don't ever try it if there's subtraction or division. Okay, now moving down. The next terms are kind of ridiculous and it's common sense. The first one that I see up here is the additive identity. That says when 0 is added to any number, the sum is the number. So a way to remember that is you see the word additive, and you're going to be adding 0. So let's just pick 4, because that's my favorite number. So 4 plus 0, we're going to get 4. That's what we wanted. We want to get the same number that we started with, so that worked. Next is the multiplication identity. So you would think it would be very similar. We will be multiplying by something, but we want to get the same result we started with. So here we're going to multiply by 1. So let's try 4 again. Got 4, multiply it by 1. 4 times 1 is 4. And again, our result was the same number we started with, so that worked. The next term is pretty obvious. The multiplication property of 0. So it looks like we're going to multiply something by 0. And that's what it is. When any number is multiplied by 0, the product is 0. Yeah, that makes sense. So 4 times 0, we got 0. That property was true. It worked. A counter example is an example that shows a conjecture is not true. So let's say that I told you, and write this down, say I said the product of even numbers is always odd. So that's telling me if I picked 2 even numbers, multiply them together, I should get an odd answer. So let's try to think of something that proves this wrong. So we have 2 is an even number. So if I go 2 times 2, I get 4. Well, this tells me I should get an odd number, but 4 is even. So this is a counterexample. It's something that shows that what I said in the first place is not true. The next word is simplify. Simplify means to perform all possible operations. We will do a lot with this throughout the year. The most important thing you need to know about simplifying is you cannot, it's very important, you cannot add or subtract a variable, so a letter, with a non-variable. A non-variable is just a number, it doesn't have a variable. But also, if the variables are different, you cannot put them together. But, so I'm going to put 2 asterisks, but you can multiply and divide a variable with a non-variable. So those are 2 very important rules that you will need to remember throughout this year. So over here, I'm going to write some examples. You can start writing some in this box if you want. I'm just going to write it underneath. So it's up to you how you want to do it. So example, and my instructions are to simplify. Example 1, we have 4 plus x in parentheses and plus 3. So my rule says I cannot add or subtract a variable with a non-variable. So here 4 is a non-variable because there's no letter. X is a variable because it has a letter. So 4 plus x, I cannot do that because they are different. They are not like terms. So I will say that a lot. If they are not like terms, that's just basically what this rule is saying. One has a variable, one doesn't, or they have different variables. So I cannot put 4 and x together. I can do 4 plus 3, because that's just 4 plus 3. We know how to do that. 4 plus 3 is 7. And I'm going to bring down my plus x. But again, I cannot put 7 and x together and get 7x, because 7 doesn't have a variable with it. So this is actually going to be my answer, 7 plus x. So we're not actually solving anything. We will once we get to equations, but we're just simplifying. We're doing anything we can. Example 2, let's have x plus 12 plus 3x. Okay, so here we have x plus 12. We cannot put those together because 12 doesn't have a variable and x is a variable. They are not like terms. So can't do that. So let's see, can I do x plus 3x? I can do that because they both have an x. So 1x, there's a little invisible 1 there, 1x plus 3x is going to give me a total of 4 x's. Then bring down my plus 12. 4x plus 12 cannot put them together because they are not like terms. 12 doesn't have a variable, 4 does. So this is going to be my answer, 4x plus 12. Example 3. We have 5 times 3r. So I said you can multiply a variable with a non-variable. 5 doesn't have a variable, 3 does, but since it's multiplication, I can put them together. So I'm just going to do 5 times 3 is 15 and stick my r out in front. So when it's multiplication and division, you just do the numbers like you normally would. So 5 times 3, and put your variable with it. Number 4, we have 12n divided by 3. So again, you can multiply a variable with a non-variable. So even though they are different terms, 3 doesn't have a variable, 12 does, you can put your numbers together. So 12 divided by 3 gives me 4. Then stick my n by it, 4n. Now let's look at one with different variables in it. So this will be our last example. Let's do 12x plus 3y plus 4y plus 5. Okay, so here we have 12x, but I don't have any other x's, which means I don't have any like terms that go with this 12x, which means 12x is going to stay by itself. Next, let's look at 3y. So I'm looking for other y's. Oh, found one. 3y plus 4y. So if I have 3 y's, I'm going to add 4 y's to it. I get a total of 7 y's, so plus 7y. And then over here I got this lonely plus 5. There's nothing else that's just a plain number. Everything has a variable, so this plus 5 is going to stay how it is. I can't put anything with my x because there's no other x's. Can't put anything else with my y, no other y's. Can't put anything with my 5 because everything has a variable. So this 12x plus 7y plus 5 will be my final answer. If you have any questions about this, you can email me and I'll do my best to answer them. Thanks.